Hello friends, welcome to Awdhesh Academy, and we are going to continue our chapter of units and measurements. And today we are going to talk about accuracy, precision of instruments and error in measurement. This is a very important issue, and let us understand what is the meaning of accuracy, what is the meaning of precision, and why the errors are happening in the measurement. What is error? Error means that whatever is the actual dimension of a particular object and what you are measuring. Suppose the actual dimension is 1.57 centimeter and you are measuring 1.5, then there is a difference in the measurement, and that difference in the measurement is called error. So what we mean by error is what is the actual dimension and what is the measured dimension. The difference of the two is error. Now this difference can be either positive or it can be negative. So for example, 10 meter can be measured either 10.1 or it can also be measured by 9.9. So both are error. In both cases the error is 0.1. So this is what we have to understand. The error means the difference in the measurement of actual size and the measured size. The second important term we have to understand is the accuracy. When we are going to measure a particular object, a particular dimension, then what is the accuracy of the instrument? So for example, if you are using a measuring scale, its accuracy may be 1 millimeter. But if you are using a vernier calipers, the accuracy may be 0.1 millimeter. And similarly, there are instruments which can measure even much smaller dimensions, and the accuracy is very high. So the accuracy means how close the measure value is to the true value of the quantity. So that is what is called the accuracy. So if you have a high accuracy, that means you have less error. So error and accuracy are opposite to each other. The next important term we should understand is the precision. Precision means the resolution or the limit of quantity which is being measured. That means every instrument will have a precision. So some instrument will have a high precision instrument, so their measurement will be much more accurate. So for example, if you are measuring a weight, so somebody can measure a weight of a person, say 50 kgs. Some instrument can measure a weight even more accurately, 50.51 kg. Some can go even further and they can say 517. That means basically they can go up to grams. So that is the meaning of the precision. So if the instrument is more precision, that means it is able to measure with more accuracy and it is able to measure with much more accurate dimensions. So let us understand with some example. For example, here you see a scale, and in this scale you can see that we can measure the dimensions up to 1 millimeter or 1 by 100 of centimeter. But on the lower side you can see that this has been even further made smaller, and therefore with this we can measure a dimension which is less than 1 millimeter. On the other side there is a weighing scale, and on the weighing scale you measure the weight of a particular object in kgs and grams, like that. So here you see that it is measured in kgs, but there are two decimals. So 0.00, as you can see, that means it can measure the weight up to 2 decimal points of kgs. So that means 0.01 kgs, that means basically up to 10 grams it can measure. So this is the resolution, this is how we can know the resolution of a particular instrument. Now let me just explain this with an example as to what is the difference between precision and the accuracy. So let us say that we want to measure an object whose dimension is 3.678 centimeter. Now we use first instrument whose resolution is 0.1 centimeter, and this is measuring you 3.5 centimeter. Then we take another instrument, this is a second instrument, and its resolution is much higher, it is 0.01 centimeter, and it is measuring the dimension as 3.38 centimeters. Now the question is, which instrument is preferable? So we can clearly see here that the first instrument is measuring the dimension more accurately, because the difference between the measured dimension and the actual dimension is much smaller. But its precision is less because it can measure up to only 0.1 centimeter. In the second instrument, we can see that the precision is high because it can measure up to 0.01 centimeter, but it is giving you more error because the actual dimension what we are measuring is 3.38 while the real dimension is 3.678, and so the error is much more. And therefore, if we have to choose one of the instruments, then generally we will go for the first instrument because it is giving you less error. So I hope you have understood what is the difference between accuracy and precision. So precision is basically a quality of the instrument. So in the second case, the precision was higher because its measurement was 0.01. But the first case, the accuracy was higher because it was able to measure the dimension which is closer to the actual dimensions. So friends, the first important thing you have to understand is that there is going to be some error in measurement. It's almost impossible to measure any particular dimension with 100% accuracy. So there is going to be an error. Now error is going to be of two types. One is the systemic error, the other is called random error. Now what is a systemic error? The systemic error means that it is those errors which tend to be in one direction, either positive or negative. That means suppose a particular instrument is measuring on a higher side, it will be measuring on the higher side, or in a particular, if it is measuring on the lower side, it will measure on the lower side. So systemic error will generally give you the error on one dimension. Now there are three different types of systemic error which is possible. The first is called instrumental error. Now what is instrumental error? Instrumental error is due to the imperfect design or calibration of measuring equipment. For example, if there is a thermometer which is calibrated in a wrong way, and so the boiling point it reflected 102 degrees Celsius. Now that's basically a systemic error. And so whenever we'll measure a particular temperature, it will be showing on the higher side. So for example, if it is 80 degrees, it will be showing you more than 80 degrees because it is calibrated on the wrong side. So it will linearly going upward because the fault is in the calibration itself. The second important thing is the 0 point error. So suppose the 0 point which we are setting, that means when the dimension is 0, it should show 0. But if it is showing any other dimension, then it is called 0 point error. So we'll explain that with some example. And here you see an example of a vernier calipers where we are going to measure and we are going to explain how the error, different type of errors takes place. So here we see three different diagrams which are reflecting three types of zero errors. In the first case, you see that both zeros are matching of the main scale and the vernier scale, and therefore there is no zero error in this particular case. In the second case, you can see that the main scale and the vernier scale is matching at 0.3, and this is the positive side, and therefore the error is 0.3 positive. In the third case, you see that they are matching at 8 point, and therefore the negative error is 0.8. And so you can see that these calibration in the second and third case are having wrong zero error, and therefore you will always have this error of measurement when you are going to measure any particular dimension. Now the second important source of error is that when we are having a wrong experimental technique. For example, you know, when you have to measure the body temperature of a person, we generally put the thermometer under the tongue. But suppose instead of that, we put the thermometer inside the arms, then the temperature will be lower than the temperature which is there in the when we are putting the thermometer on the mouth. And so this is a type of error which is because of the wrong measuring technique. In the same way, suppose you want to measure the speed of sound, and speed of sound also depends upon the speed of the wind. Now suppose that there is a wind flowing. In that case, if the wind is on the direction of the sound, then naturally the speed will be higher, and if it is on the opposite direction, then the sound speed will be lower. And therefore this type of error may be possible because of the wrong experimental technique. So if you don't measure, for example, the speed of the air, and then you measure the speed of the sound, there will be error. So you have to adjust these things to get the accurate dimensions. Then the third type of error is the personal error. For example, here if you see, if you are measuring a particular dimension from a scale, and you have a tendency to look the scale from the top, in that situation there will always be error because you tend to measure the dimension on the higher side. Ideally, you should see the scales just on the eyes length. If you are seeing just on the eyes length, you will get the right dimension. But if you are seeing on slightly on the lower side or slightly on the higher side, then the dimensions will be wrong. And so this is basically a personal error, and people have the tendency to sometimes see only the lower side or sometimes see the higher side, and they tend to commit the mistakes on the same direction. Now the question is that can we reduce the systemic error? Yes, it is possible to minimize the systemic error, and how we can minimize this is like this. The first method is that you should have better experimental techniques. So for example, as I said that suppose you are measuring that speed of the sound in air, then if the air is stationary and if you can see that there is no air, then definitely you can measure the speed of the sound much more accurately. Second is that if you select the better instrument, the instrument which is having a high precision instrument and the instrument which does not have any zero error, then you will be able to measure the dimensions in much more accurate method. And third is that if you remove the personal biases, that means if you measure the things exactly as you are supposed to measure without on the lower side, without on the higher side, then also the systemic error can be minimized. Now, the first type of error, as I told you, is about the systemic error. The second type of error is the random error. Now, the random errors are those type of errors which occurs irregularly, and these are random because we do not know whether on the higher side or whether they are on the lower side, and that is the actual meaning of the random errors. Now, this may be possible because of several reasons. For example, it is possible because of the fluctuation of the temperature or voltage. For example, if you want to measure the density of oil, let us say, in that situation if the temperature fluctuate during the measurement time, then that type of error is possible. And so this will be random because we do not know whether it's going on the higher side or going on the lower side. So in the same way, if there is a mechanical vibration on the experiments, if you are doing an experiment, there is a mechanical vibration, and that can also contribute to the error of the instrument. And finally, that you have this personal biases which is unbiased, means if suppose 5 people see some particular measurement, then some people see on the higher side, some people see on the lower side, and therefore that type of error will also be a random error. Now let us understand the concept of least count. Every instrument has a least count, and least count means this is the minimum dimension which can be measured by a particular instrument. So for example, if you are having an ordinary scale, its least count is 1 millimeter. That means it cannot measure a dimension which is less than 1 millimeter. You have to approximate the dimension to 1 millimeter or 0.1 centimeter. So this is the least count measurement. In the same way, for example, if you are using a vernier calipers, it can measure the dimension up to 1/100th of the centimeter or 0.1 millimeter. If you are using a spherometer, then its least count is 0.01 millimeter. So every instrument will have a different least count, and least count will basically tell you the accuracy of the measurement. And when you know the least count of the particular instrument, you know that that much of error is possible. So if the least count of the instrument is say 0.1 centimeter, that means the error possibility is 0.1 centimeter due to that instrument. Now, how can you minimize the least count error? If you want to minimize the least count error is that if you measure the things into multiple times. So suppose you have to measure a dimension of a particular box or particular bench, then you measure it, let us say 10 times. And if you measure it 10 times and then you take the average of that, then the errors will be minimized. So that is the best method of reducing the least count error. Now we will be continuing as to how to measure the absolute errors, how to measure the different type of errors, and this we will continue in the next session. Thank you very much for watching this lesson, and we'll continue with this lesson in the next session. Don't forget to watch the next session. Thank you.